Hello, everyone. Welcome back to Python Challenge for All. Okay, good. So it seems fine. If I click 7, we can move it. If I click 4, nothing happens. 1, 3, 2, 8, 5, 4. Hello, everyone. Welcome back to Python Challenge for All. So we are having fun with the 8 puzzle development. So last time we successfully um, yeah, uh, caught the click event and printed the number of panel to which was clicked. So let's do next thing is move the panels according to the clicks. So okay, today's work, check if the clicked panel is movable. That's important next to 0. So the point is compare the index of the empty panel and the index of the clicked panel. Okay, let's go. So from here, the first of all, the empty panel number index is can be obtained like this: self-board dot index 0, meaning the returns the index of the 0 element in the list of self-board. So let's do that. So after each panel, maybe we can write here, or we can make our, let's see, yeah, what shall we do? Let's make a separate function to take care of the panel movement. So maybe we can here write move tile, move panel, panel, self. No, yeah, move panel. And then here we define a method to take care of that. Move panel. The first element should be always self. And then, yeah, also I should give the clicked position of the in the index of the clicked panel, cpos, to that function. Okay, so the second element should be cpos. Okay, clicked position. So first, let's find the index of the empty panel, which is self-board.index 0. Okay, so this is the 0 pos. So this means we should, yeah, compare the, yeah, if its neighbor to the empty or not can be calculated as Manhattan distance between the clicked panel and the empty panel is 1. Okay, so maybe you know what. Okay, let's let's check that. So here, if the empty panel is here, we want to move the panel only when we click 7, 1, or 4 and do nothing otherwise, right? So here, the Manhattan distance, in other words, taxi cab distance between the two are 1. So let's make a function to calculate the Manhattan distance. So this will be kind of a global function. Maybe we might use it from different positions. Different Manhattan dist of panel 1 and panel 2 can be calculated as, so as for panel 1, the x distance, x coordinate can be expressed as p1 percentage nn, and y coordinate can be calculated as p2 slash slash nn. Likewise, the same thing. No, sorry. This should be 1. Okay? And do the same thing for P2. So X2 and P2, P2, and P2. Okay. So the Manhattan distance can be calculated as abs x1 minus x2 plus abs y1 minus y2. So if the Manhattan distance can be calculated as, yeah, x coordinate difference plus y coordinate difference. Okay, so maybe this can be used uh, globally. Okay, so what we need to do here is using the Manhattan distance. Okay, like this. If movable means Manhattan distance is 1. So, okay. So maybe we can do, maybe this is not necessarily always, maybe first condition is this, okay? Whether CPOS is between 0 and 8. And also, index, okay? And also the second condition is if Manhattan dist of CPOS and 0 pos is 1. So this is the condition to move, to check whether the CPOS clicked panel is movable. Okay, in that case, move the panel and redraw, swapping the panels. Okay, so empty panel, yeah, clicked value should be assigned to empty panel. This is strange. Okay, so what we should do is self board 0 pos equals clicked panel. Okay, self board CPOS. Okay, and then likewise, clicked should be changed to 0. Okay, self dot board CPOS is 0. Okay. Okay, this is all. So, okay, let's check if this works. And now the board configuration is changed, so automatically it will be reflected in the draw function. So let's check that. Redraw after the move, it's done automatically. Let's check that, okay? So here, if we click this, no change. What's wrong? Okay, let's check that. Maybe because I commented this out. So let's comment in. So move panel, okay? Okay, so this, if I click this, move panel is not defined. I should call self dot move panel. Okay, move panel is a class function, so maybe I should call self dot move panel cpos. Okay, let's call that. So if I click this, 0 pos, maybe some mistake. 23. Maybe you notice this. 0 pos. 0 pos. Okay, sorry. 0 pos. Okay. Is this all? Hopefully, yes. Okay. So if I click this, again, list is not callable. Why did I do this? Of course, it should be square bracket instead of a round bracket. Okay, good. So it seems fine. If I click 7, we can move it. If I click 4, nothing happens. 1, 3, 2, 8, 5, 4. So maybe we can remove or move this line to, remove this line now. Okay. So seems fine, right? Very beautiful. Okay. So let's check that everything is fine and we can move whatever yeah, whatever movement we can make valid moves. We don't, yeah, if I click these, nothing happens. Beautiful. Okay. So what's next? Oh, yeah, good. So it seems everything is fine. Maybe we will finish up the panel next time and see that, yeah, find out that all the board configuration are solvable. We can go to that next time. So, okay, please come back next time. That's all for today. See you next time. Bye bye.